Dear students, welcome to my classroom. In previous part of progression chapter, we solved some problems in exercise 6.3 which are related to sum of n terms of an arithmetic progression. And in this class, we are going to complete this exercise. So let's take the next problem, that is eighth one in exercise 6.3. If the sum of the first n terms of an AP is 4n minus n square, what is the first term? What is the sum of first two terms? What is the second term? Similarly, find the third, the 10th, and the nth terms. So here it is a hint given that the first term is S1. And we also know that the sum of first one term is equal to the first term, isn't it? A1 is equal to S1. So that is the given in problem. And also it is given that sum of n terms, that is Sn is equal to 4n minus n square. And we need to find the first term, sum of the first two terms, second term, third, 10th, and nth terms also. Okay. So in given AP, it is given that sum of n terms, the sum of first n terms is Sn is equal to 4n minus n square. And by substituting 1 in place of n, we get S1, which is equal to A1, that is the first term. Okay. And by substituting n is equal to 2, we get the sum of first two terms, that is S2. And similarly, by substituting 3 and 4, like that, we get the sum of first three terms and four terms, that in that way. Okay. So now the first term of AP is A1 is equal to sum of first one term, that is S1. And by substituting 1 in this Sn, we get S1. So that is 4 into 1 minus 1 square. That is 4 minus 1, which is equal to 3. So the first term of given AP is A1 is equal to 3. And now sum of first two terms. Sum of first two terms is S2. So by substituting n equal to 2 in Sn, we get the value of S2. That is first sum of first two terms. So S2 is equal to 4 into 2 minus 2 square. That is 8 minus 4 is equal to 4. And now it is asked that what is the second term? We know that Sn is equal to An is equal to Sn minus 1. That is subtracting the sum of n minus 1 terms from sum of n terms, we remains with the nth term An. That is An is equal to Sn minus 1. So in that way, the second term A2 is equal to S2 minus S1. Okay, by substituting n is equal to 2 in this formula, we get A2 is equal to S2 minus S2 minus 1, that is S1. So A2 is equal to S2 minus S1. And we have A2 is equal to S2 is equal to 4 and S1 is equal to 3. So that A2 is equal to 4 minus 3, which is equal to 1. So now we got this second term also. And similarly, the sum of third term, that is, the final, similarly, the third term A3 is equal to S3 minus S2. 10th term A10 is equal to S10 minus S9. Nth term An is equal to Sn minus 1. Okay. So the third term A3 is equal to S3 minus S2. And we get S3 by substituting n is equal to 3 in given Sn. So S3 is equal to 4 into 3 minus 3 square, as well as S2 is equal to 4 into minus 2 square. So that S3 minus S2 is equal to 4 into 3 minus 3 square minus 4 into 2 minus 2 square. And we have 4 into 3 is equal to 12, 3 square is 9, 4 into 2 is 8, 2 square is 4. So in that way, we get A3 is equal to 3 minus 4, which is equal to minus 1. So the third term is minus 1. And now 10th term is A10 is equal to S10 minus 1, that is S9. And S10 is equal to 4 into 10 minus 10 square. S9 is equal to 4 into 9 minus 9 square. So A10 is equal to 4 into 10 minus 10 square minus 4 into minus 9 square, which is equal to 40 minus 100 minus 36 minus 81. And simplifying this one, we get A10 is equal to minus 15. And also, nth term is An is equal to Sn minus 1. That is 4n minus n square minus 4 of n minus 1 minus n minus 1 whole square. That is, we are substituting n minus 1 in place of n in Sn. So 4n minus n square minus half. 4 into n minus 1 is 4n minus 4. And we know that n minus 1 square is n square minus 2n plus 1. But we have minus in before n minus 1 whole square. So we have to multiply with minus all the terms of n minus 1 whole square. That is minus n square minus into minus plus 2n minus into plus minus 1. And by simplifying this equation, we get an is equal to 5 minus 2n. So in that way, we got eighth one is equal to 3. That is first term is equal to 3. Sum of first two terms S2 is equal to 4. Second term A2 equal to 1. Third term A3 is equal to minus 1. 10th term A10 is equal to minus 15. Nth term An is equal to 5 minus 2n. In other way also we can solve this problem. After finding A2 is equal to 1, already we got that A1, that is first term is 3. And after finding A2, we can find the common difference D is equal to A2 minus A1. And after that, we can find sum of first two terms. And we can find second term A2, that is A plus D. And third term A plus 2D. 10th term A plus 9D. Nth term A plus N minus 1 into D in that way. Okay. So you can solve in these two methods. Now take the ninth problem. Find the sum of the first positive integers divisible by 6. And students, the positive integers that are divisible by 6 are 6 into 1, 6 into 2, 6 into 3. First one is 6 into 1, second one is 16 into 2, third one is 16 into 3. And in that way, 40th one is 6 into 40. Okay. So the first positive integers that are divisible by 6 are 6 into 1 is 6, 6 2 is 12, 6 3 is 18, like that up to 640 is 240. So now these terms are in AP because the difference throughout the sequence is equal to 6. It's same. So as the common difference throughout the sequence is same, these numbers are in arithmetic progression. And the first term is A equal to 6. Common difference D is equal to 12 minus 6 is equal to again 6. And the number of terms in this progression, we are finding first 40 positive integers. So the number of terms is n is equal to 40. Now, the sum of these 40 positive integers are divisible by 6 is n by 2 into a plus n. We have the formula sum of n terms is Sn is equal to n by 2 into a plus n. In that way, sum of 40 terms is S40 is equal to 40 by 2 into A is first term 6 plus L, that is the last term 240. And by simplifying it, we get 20 into 246, which is equal to 4920. So the sum of the first 40 positive integers that are divisible by 6 is 4920. Okay, it's a very easy problem and also a very important problem for board exams. Okay, so let's take 10th one. A sum of 700 rupees to be used to give 7 cash prizes to students of a school for their overall academic performance. If each prize is 20 rupees less than its preceding price, find the value of each of the prizes. Okay, students. So there are 7 prizes to distribute among the students. So each price, the value of each price is 20 rupees less than its preceding price. That is, the value of second price is less than 20 rupees less than first price, and value of third price is 20 rupees less than second price, in that way. Okay, so it is given that sum of all cash prices is 700 rupees. Now, it is also given that value of each price is 20 rupees less than its preceding price. Let the value of the first price be x rupees. Then the value of second price is 20 rupees less than first price, that is x minus 20. And the third price is x minus 20, again minus 20, x minus 40, in that way. So then the consecutive values of prices are x minus 20, x minus 40, x minus 60, x minus 80, x minus 100, x minus 120. These are values of 7 prices starting from x and decreasing by 20 for each price. Okay, x, and by decreasing 20, we get x minus 20, again by decreasing 20, x minus 40, again by decreasing 20, x minus 60. In that way, we have 7 prices up to x minus 120. So these, we can observe that these terms are also in AP, because each term is decreasing by 20 here. There is the common difference is same. So these terms are in AP with first term a is equal to x and the common difference d equal to minus 20. Okay, common difference d equal to minus 20, and the number of prices, that is number of terms, is 7. Now sum of all these cash prices from x rupees to x minus 120 rupees is 700 rupees. But we have sum of n terms is Sn is equal to n by 2 into FSL. That is, sum of these cash prices is 700 and n is equal to 7, a is equal to x, l is equal to x minus 120. So by substituting all these values in this equation, 700 is equal to sum of 7 terms is S7 is equal to 7 by 2 into x plus x minus 120. But the sum of 7 terms is nothing but sum of all cash prices, which is equal to 700. So, but first, so simplify this one, 7 by 2 into 2x minus 120, that is 7 into x minus 60. But sum of 7 cash prices is 700. So there is sum of 7 terms is 700. So 700 is equal to 7 into x minus 60. And from this we can write x minus 60 is equal to 700 by 7, which is equal to 100. And x is equal to 100 plus 60 is equal to 160. So in that way we got first value of first price as 160. And by substituting 160 in these values, we get our values of all prices. Okay, so values of each price from first price are 160, 160 minus 20, 160 minus 40, 160 minus 60, 160 minus 80, 160 minus 100, and like the 160 minus 120. That is, the values of all prices from first prices are 160, 140, 120, 100, 80, 60, and 40. Okay, students, this is the solution of this problem. And take the 11th one. In a school, students thought of planting trees in and around the school to reduce air pollution. It was decided that the number of trees that each section of each class will plant will be the same as the class in which they are studying. For example, a section of class 1 will plant 1 tree, a section of class 2 will plant 2 trees, and so on till class 12th. There are 3 sections of each class. How many trees will be planted by the students? Okay, students. There are 12 classes in school, and each class consists of 3 sections. And it was decided to plant the trees such that each class will plant the number of trees is equal to their class, And example also given here. The students of class 1 will plant one tree because they are of class 1. And the students of class 2 will plant two trees. And similarly, students of class 12 will plant 12 trees, like that. And each class has 3 sections. So how many trees will be planted by the students? That is the question. Okay. So there are 12 classes in the school. Each consists of 3 sections. So that trees planted by each section is equal to 3 into class number. Okay. Trees planted by one section is equal to class number. And in that way, trees planted by all sections is 3 into class number. So then the number of trees planted by classes from 1 to 12 are 3 into 1, 3 into 2, 3 into 3, up to 3 into 12. That is 3, 6, 9, up to 33 and 36. Now, these numbers are in AP with first term A is equal to 3, common difference D is equal to also 3, and the number of terms is 12 because there are 12 classes in the school. And now the number of trees will be planted by students is equal to sum of the 12 terms of this progression. And we know that sum of n terms in the progression is n by 2 into a plus l. So in that way, we have n is equal to 12, a is equal to 3, and l is equal last term 36. So 12 by 2 into 3 plus 36, that is 6 into 39 and equal to 234. So the number of trees will be planted by students is 234. Okay, students. So take the 12th one. A spiral is made up of successive semicircles with centers alternately at A and B, starting with center at A of radii 0.5 centimeter, 1 centimeter, 1.5 centimeter, 2 centimeter, like that as shown in figure. What is the total strength of such a spiral made up of 13 consecutive semicircles? And it's given that take pi is equal to 2 by 7. And here hint is the length of successive semicircles is L1, L2, L3, L4, like that with centers A, B, A comma, B comma, A comma, B respectively. Okay, students, here is the figure here. So there are two centers, and with center A, there is a semicircle L1, and as center B, semicircle L2, and as center 3, semicircle L3, as center 4, semicircle L4, like that. So in this way, there are 13 semicircles in a spiral. There is up to L13. So what is the total length of the spiral? That's the question. Okay, students. So there are 13 semicircles in the spiral whose radii are first radius of first semicircle is R1 is equal to 0.5 centimeter. Radius of second circle is second semicircle is R2 is equal to 1 centimeter. And radius of third semicircle is 1.5 centimeter. And fourth semicircle is 2.0 centimeters, like that. Okay. Now, lengths of consecutive semicircles are L1, L2, L3, L4 up to L13. Now, total length of the spiral is L1 plus L2 plus L3 plus L4 up to L13. But L1 is the length of semicircle, and that is the circumference of semicircle is pi r. So here we are excluding radius. Okay. So excluding diameter. So that only its length is equal to L1 equal to pi r. So in that way, we have pi r1, pi r2 plus pi r3, pi r4 up to pi r13. And taking r1 is equal to 0.5, r2 equal to 1, r3 equal to 1.5, r4 equal to, we have 13 terms. And taking pi into 0.5 common, 1 plus 2 plus 3 plus 4 up to 13 terms. And we have pi is equal to 22 by 7 and sum of these 13 terms. So it's an AP with first term 1, common difference 1, and we have 13 terms. So the sum is n by 2 into 2a plus n minus 1 into d. So we are using Sn is equal to n by 2 into 2a plus n minus 1 into d, where n is equal to 13, a is equal to 1, d is equal to 1. And now 22 into 0.5 is 11. 11 into 13 is 143 by 7 into 2, 14. So product of these three terms is 143 by 14, and the value in the bracket is 14. 2 ones are 2 plus 13 minus 1 is 12. 2 plus 12, 14. And by cancelling 14 and both numerator and denominator, we remains with 143. So which is the sum of 13 terms, that is the sum of all semicircles. So the length of spiral, total length of the spiral is 143 centimeters. Okay. Now take the 13th one. 200 logs are stacked in the following manner. 20 logs in the bottom row, 19 in the next row, 18 in the row next to it, and so on. How many rows are the 200 logs placed and how many logs are in the top row? So here the figure is given. So there are 200 logs stacked in a manner that 20 logs in first row, 19 logs in second row, 18 logs in next row, like that. So how many rows were needed to place 200 logs? That is the first question. And how many logs are in the top row? That is the second question. So, okay. So let's solve the problem. So total number of logs stacked is 200. Now, number of logs stacked in first row is 20. And in second row is 19. Third row is 18. And so on. So these numbers 20, 19, 18 and so on in AP with the first term a equal to 20 and common difference d is equal to minus 1. We know that d is equal to a2 minus a1, 19 minus 20, which is equal to minus 1. And now let the number of terms, that is number of rows of the logs, be n. Now sum of these n terms is Sn is equal to n by 2 into 2a plus n minus 1 into, which we have known. That is sum of n terms is nothing but sum of the logs in all rows is 200 is equal to number of rows we don't know, and we know the value of a is 20 and d is equal to minus 1, so we are substituting in this equation. So 200 is equal to n by 2 into 20 plus n minus 1 into minus 1. So by transforming this 2 to left side, 200 into 2 is equal to n into 220 is a 40 minus n minus into minus plus 1. That is 400 is equal to n into 41 minus n, and 400 is equal to 41 into n minus n into n square. And transforming these two terms to right side, we get n square plus minus 41n plus 400 is equal to 0. And students, we can observe that this is the quadratic equation in the variable n, and we can solve this quadratic equation using factors method. So we can split this minus 41 into minus 25 and minus 16, because minus 25 in minus 16 is minus 41 and minus 25 into minus 16 is 400. And by taking n common in first two terms and by taking minus 16 common second two terms, we get n minus 25 into n minus 16 equal to 0. And from this, we get n is equal to 25 or 16. But there can't be 25 rows as we are starting with 20 logs in the first row. So after 20th row, it becomes 0. And in 21 row, we have to put minus 1. But it is not possible to put minus 1 logs in any row. So there can't be 25 rows. So n must be 16. That is the number of rows must be 16. Now the number of logs in top row is equal to 16th term of AP, because we have totally 16 rows. So the number of logs in the top row is 16th term of the AP. That is A plus 15D. We have A equal to 20 and D equal to -1. So 20 minus 15, which is equal to 5. So 16 rows were needed to 200 logs placed, and the number of logs in the top row is 5. That's the answer. Okay. So take the last question in this exercise. In a bucket and ball race, a bucket is placed at the starting point, which is 5 meters from the first ball, and the other balls are placed 3 meters apart in a straight line, like this. There are 10 balls in the line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. A competitor starts from the bucket, picks up the nearest ball, runs back with it, drops in the bucket, runs back to pick up the next ball, runs to the bucket to drop it in, and she continues in the same way until all the balls in the bucket. What is the total distance the competitor has to run? So here it is given that to pick up the first ball and the second ball, the total distance run by competitor is 2 into 5 plus 2 into 5 into 3, like that. 2 into 5 plus 3. Okay, friends, that is the question. So there are 10 balls, and a competitor to be run from bucket to ball, and to pick the ball and to be placed in bucket by going to back, and again she must be run for second ball, and again she has to pick it up, and by running back the ball to be dropped in bucket, like that. So in this way 10 balls to be completed. So how much distance will competitor to run? That is the question. So balls are placed at a distance of 3 meters from each other, as given in problem. Now the distance of first ball from bucket is given as 5 meter, and the distance of second ball from bucket is 5 plus 3 equal to 8 meters. That is 5 plus 1 into 3. And the distance of third ball from bucket is 8 plus 3. That is 11 meters. It is equal to 5 plus 2 into 3. In that way, the distance of 10th ball from bucket is 5 plus 9 into 3. For first bucket, for second bucket, 5 plus 1 into 3. For third bucket, 5 plus 2 into 3. And for 10th bucket, 5 plus 9 into 3. That is 5 plus 27, which is equal to 32 meters. And the distance covered by the competitor for first ball, that is to pick it and drop in the bucket, the distance covered by the competitor is 2 into 5, which is equal to 10 meters. And distance covered by the competitor for second ball is 2 into 8. So to run from bucket to ball and ball to bucket, 8 plus 8, 16. And for third, 11 plus 11, 22. And in that way, for distance covered by the competitor for 10th ball is 2 into 32, that is 64 meters. Now, distances covered by the competitor for all balls are 10 meters, 16 meters, 22 meters, like that up to 64 meters. So we can observe that these numbers are in AP with first term A is equal to 10, common difference D is equal to A2 minus, that is 16 minus 10 is 6. And there are 10 balls, number of terms is 10. And the total distance covered by the competitor is equal to sum of n terms of this AP, where n is the last term, that is 64. So n by 2 into A plus n, we have 10 by 2 into 10 plus 64. is 5 into 74, which is equal to 370. So the total distance covered by the completer is 370 meters. Okay, students, that's all for today. So that's the end of this exercise also. And in next class, we are going to learn about geometric progression, which is the second one in the progressions. So until then, see you. Bye.